I'd like to provide a little bit of background on the Amazon Web Services platform. We'll dive into a couple of the most relevant services in detail throughout this presentation. But at the very foundation of Amazon Web Services, we have a global infrastructure. So these are the regions of multiple data centers that we have around the world. And these extend from Europe with our data centers in Dublin, East Coast of the U.S. in Northern Virginia, West Coast in Northern California, in Oregon. We have regions in Tokyo, in Singapore, Sao Paulo. And for workloads that are involve software or data sets that are ITAR controlled, we have a U.S. GovCloud region that's also based in Oregon. And within each region, we have a metropolitan area network of data centers. And we call each of these data centers an availability zone. And I'll talk about why those are named availability zones in just a bit. In addition to the regions that I just mentioned, we also have a content delivery network with edge locations in each of those regions, but many others, so that we have about 33 points of presence around the world. So if you're wanting to replicate a data set or make images available to others that you're collaborating with, or if you want to, for example, share the latest images of Mars, as NASA JPL is about to do with the landing of the Mars Science Laboratory, you could use a service like Amazon's CloudFront to deliver that content to viewers around the world. On top of this region of data centers, we have compute capabilities, Elastic Compute Cloud, which you can either provision servers in a onesie-twosie fashion or launch a batch of 50. Or if you want, you can define a group of servers that will automatically scale to meet your needs. So if you have an unpredictable amount of work that might be coming your way. So, for example, you have a predefined cluster that typically has about 10 nodes in it, but maybe once a day or a couple of times a week, very large data sets come in that you need to pre-process so that you can get a further analysis on it. You could set up auto-scaling rules that would automatically provision additional nodes while that large amount of work is heading your way. Once that work is completed and the machines start to become less busy, automatically turn off a percentage of the members of that cluster. We have a number of storage services, S3 being an object store. Elastic Block Storage is a block device that we offer. We also recently launched SSD-based instances, and we'll talk about all of those in just a bit. You can run databases and really any other software that you like on your Elastic Compute Cloud or EC2 virtual machines. You get full access to a Windows or a Linux operating system, Windows Admin or Linux root access. And you can install any software you like and then manage that software yourself because you have access to the operating system. We actually don't have that access, so it's your responsibility to keep that patched and updated. If you'd prefer to have Amazon take on the management of things like databases, we have our relational database service built on Oracle, MySQL, and SQL Server. Our own NoSQL databases, both SimpleDB and one built on the Dynamo engine called DynamoDB. And we also have an implementation of Memcache called Amazon Elastic Cache. At the networking layer, we have DNS services, direct connectivity options. So if you want to have one or more 1 gig or 10 gigabit links, and have network pairing with Amazon, that's a possibility and something that's frequently used by our scientific customers. And we also have load balancing and virtual private cloud capabilities that allow you to seamlessly integrate an on-premise network with the Amazon cloud. On top of this platform, as mentioned, we have content distribution, messaging, queuing, workflow APIs that are actually very important. So if you're working on one example of this, Mars exploration rovers and Mars Science Laboratory. As images are captured by the rovers on Mars, transmitted to orbiting satellites, sent back to the Deep Space Network, arrive at Pasadena, workflows trigger that take those images, immediately upload those to Amazon S3. Will then generate panoramas that allow scientists at JPL and actually around the world to quickly identify areas that are potentially hazardous or also scientifically interesting, and generate the next sequence of commands that are transmitted back to the rovers. That workflow that I just mentioned is all coordinated through these types of platform services that are offered within the Amazon cloud. Workflow the Amazon Simple Workflow Services, notifications engines, as well as dynamic provisioning of clusters that for that period of time when images are coming in, and it's important to get that panorama generated very quickly so that you can optimize the time that researchers have to generate the sequence of commands as opposed to processing images, that will spin up a large number of EC2 instances for that period of time. And then a number of monitoring and management and administrative capabilities built on top of this. And then, of course, most importantly, you can then run your applications on this platform, either directly on top of EC2 or integrating as the Mars workflow that I just mentioned as integrating a number of our platform services.